Hi everyone, this is assignment 14. It's our second review day before our assessment on the Trig Basics unit. Okay, how about this question? What quadrant do I live in? What quadrant do I live in? Theta equals 9 pi over 8. What quadrant do I live in if I'm looking at theta is 9 pi over 8? Well, yeah, I don't have any over 8s on my unit circle, but that doesn't mean we can't have an understanding. You know, this is pi over 2 and pi and 3 pi over 2 and 0, 2 pi here. Well, let's convert these into eighths. So this needs 4 over 4. That's 4 pi over 8. And this needs 8 over 8. So this is 8 pi over 8. If I multiply here by 4 over 4, I get 12 pi over 8. So where's 9 pi over 8 live? Well, 9 pi over 8 is a little bigger than 8 pi over 8 and less than 12 pi over 8. So I'd have something like this for 9 pi over 8. And therefore, I'm in quadrant 3. Okay? All right, so how about you do one or two of those? Here we are. Theta equals 15 pi over 7. Theta equals 15 pi over 7, and I just want to know what quadrant. What quadrant is 15 pi over 7? Give it a try. Pause the video, see what you can come up with. Oh, hi, welcome back. So, this is normally pi over 2. And if I multiply by 7 over 7, well, I guess I could do 7 halves, 7.5 pi over 14. Yeah, so if I multiply this by 7.5 and 7.5, that, no, I don't want 7.5. I want to turn pi over 2 into something over 7. So that means I need to multiply it by 7 on the bottom and 2 on the top. So those cancel. No, I can't do that because that's not 1. There we go. 7 halves. So 7 halves. 7 pi over 2 over 7. Yeah, that's it. Though when I do the flip and multiply, I am going to end up with 7 pi over 14, which brings me back to pi over 2, so I don't want to go there. I'm just going to say 3.5 pi over 7, because 7 divided by 2 is 3.5. And what about over here? Well, this would be 7 pi over 7. And here, well, that's going to be 11.5 pi over 7. How did I get that? Well, I want 3 pi over 2 to turn into something over 7. So I'm going to have to multiply here by 7 over 2, and on the top, 7 over 2. And so then these cancel, leaving me at 7. And here I have 21 pi over 2. But when I do the flip and multiply, notice that these can cancel. Oh, that brings me back. No, I don't want to do that. Yeah, so instead, I've got 21 pi over 2 over 7. Well, 21 over 2 is not 11.5, it's 10.5. So there we go. And which angle were we doing? 15 pi over 7. Mon Dieu, this one's 14 pi over 7. 15 pi over 7 is just a little past that. And so our angle is this angle, and it ends up in first quadrant. Whew, that's tough thinking, but thinking's good. Don't worry, thinking's good. Okay, Well, we did coterminal angles and positive and negative angles and complements and supplements in the first video, so I don't know that we need to do that. Hmm. Hmm. Ooh. Okay. We have a flagpole at school by the library. The angle of elevation from the little ant's head to the top of the flagpole, it's the waving flag, is 70-degree angle of elevation. And what we'd like to know is how tall is the flagpole. And the ant walked 20 feet back from the flagpole. It did take a while. The ant was very curious to know how this would turn out. And so Ant wants to know the height of the height of the flagpole. So how are they going to do that? What do they need in order to figure this out? Well, I really like that idea. That idea of needing to pick a trig function, which trig function uses opposite and adjacent. Tangent 70 degrees is opposite over adjacent. So if we multiply both sides by 20, we get 20, 10, 70. Ooh, am I in the right units? These are degrees. I better check. Uh-oh, I was in radians. Yeah, you won't believe how many problems people get wrong because they don't pay attention to what their calculator is set on. And so I get that h equals 54.9495 or 54.95 feet. And that's our flagpole. Okay? All right. Hey, so, one of the things that happens when you grow up in New York City, like I did, is that you learn really interesting, strange facts. Like, there was a World War II bomber, because of fog, actually flew into the Empire State Building in the 1940s. That didn't cause the building to fall down, but it was quite shocking, very scary out here from the people who were there at the time. So let's think about that. If you're standing, you know what else? If you look, and go check it out on the web. If you look at the top of the Empire State Building, there's this little ring up here, and it's your dirigible or blimp docking ring. Yeah, in the 1930s, they were thinking it might be cool for us to take our airships and dock our giant blimp to the docking ring. They did it once, and there was this little causeway that was pushed out, and oh my God, the winds were so strong. Nobody died, but everyone agreed we would never do that again. But there is a docking ring up there, so if you ever get your own dirigible, you can pull it up there. It's just a hoot. Okay, so what I want to say is, if you are up here on the observation deck of the Empire State Building, you can look down with an angle of depression of 2 degrees, 14 minutes, and 4.38 seconds. Okay, and you'll be able to see what's over there. Ooh, It's that ant we were talking about. So, remember, angle of depression is not this. This is not the angle of depression. When you write the angle of depression in here, yeah, what that's going to tell me is you're not watching the videos. This is the angle of depression. You looked straight out and you had to depress your eyes. Okay? This is you looking at your shoes and having to raise your eyes. No, 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 no. It's the angle of depression. So that's 2 degrees, 14 minutes, and 4.38 seconds. All right? What else do I know? Ooh, I know the height of the Empire State Building is approximately 1,250 feet. And if you want to see a really tall building, go look up the Burj Khalifa. Yeah, now that's a tall building. Okay, so what would we like to know? Well, how far away from the Empire State Building is the ant? What's that distance? Okay, so how are you going to figure this out? Well, I love that idea of saying you're looking for a side, you've got another side. Also, isn't the angle of depression, you looking down to see the ant, isn't that the same as the angle of elevation? Sure is. Okay, so what trig function would I use with this angle? Opposite, adjacent, sounds like tangent. So I can say that the tangent of theta is 1250 over d. Now we know theta, that's this angle. So I want the tangent of 2 degrees, 14 minutes, and 4.38 seconds. Cool. Oh, but wait. I want this to say d equals. D's on the bottom. No bueno. So equals 1250 over d. Well, so I'm going to say let's multiply both sides by d, but I want d alone. So I need to divide by the tangent of 2 degrees, 14 minutes, and 4.38 seconds. So over here, tangent 2 degrees, 14 minutes, and 4.38 seconds. 1250 divided by that tangent. 1250 divided by tangent 2 degrees. Oh, okay. Mode, degrees, good. Tangent 2 degrees. And 14 minutes and 4.38. Remember, it's over here next to the plus. Seconds. And close parenthesis. So we get 32,034.821 feet. And since there are 5,280 feet in a mile, that's about 6.067 miles away. All right. Wow, that ant. You could really see it. Well, you know, there are those little high-power binocular telescopes up there on the observation deck. So you could certainly see 6.1 miles away. I don't know if you could make out an ant. I was never able to see that clearly, but it is cool being up there. And it's got a dirigible docking ring. Okay, well, there's one last type of problem that I think would be nifty for us to look at, and that is the distance between cities problems. Okay? So, distance between two cities. Florence, beautiful town in Italy, is located at 43 0.7696 degrees north latitude, and Berlin, Germany, is located at 52.52 degrees north latitude. We know that the Earth is approximately 4,000 miles in radius, but let's use the more accurate 3964. And no, you're not going to have to know those numbers. Those numbers will be provided in the problem. And then you're leaving it up to the person who's giving you the problem to decide how rounded they want that to be. Do we want to go with 4,000? Why not go with 3964? We're certainly going to use a calculator here. Okay, so how do we do this? Well, remember, what we're thinking about here is this distance. Okay, so here's Florence, and here's Berlin. We know the radius of the Earth, and we're looking for that distance. That's arc length. Do you remember the arc length formula? Oh, I hope so. S equals R theta. Hey, and what had to be true about theta when you use this formula? Yeah, no, you really need to know because you're going to get the problem wrong if you don't. Theta must be in radians. So even though I've been given degrees to start this problem, I'm going to have to convert to radians in order to use this. Okay? Well, let's focus on this angle. This angle is the difference for the latitude of Berlin and the latitude of Florence. So I could subtract. They're already in decimal degrees. If they had been given to me in degrees, minutes, and seconds, the first thing I'd want to do is put them in decimal degrees, because then I could actually just do some subtracting. 43.7696, and I end up with theta being 8.7504 degrees. So this angle in here is 8.7504. So can I just do this and say S equals 3964 times 8.7504? No. No, weren't you listening? Theta has to be in radians. That's degrees. See? Degrees. So I have to convert that. Okay, so how do I convert? Well, remember, when we're going from degrees to radians, the degrees on the conversion factor are on the bottom. So I'm going to take this angle, I'm going to multiply by pi, and I'm going to divide by 180. So I'm going to multiply by pi, and I'm going to divide by 180. Okay, so now I have my angle as 0.1527232909. There. So I'm going to multiply times 3964. And I get that the arc length is 605.395 miles. Berlin is 600 miles north of Florence. Any questions about that? Okay, well, I think you should do this one. Well, that's very interesting. Okay. I think you should do this one. Madrid is located at 40 degrees, 24 minutes north latitude. And that's very interesting. And Palermo is located at 30 degrees, 7 minutes, 55.38 seconds north latitude. Yeah. And again, I'd like to know the distance between those cities. At least how far north Madrid is of Palermo. Okay, so give it a try. Oh yeah, radius of the Earth is still 3964, and those are miles. So this is 30 degrees, 7 minutes, 55.38 seconds. And up here we have Madrid at 40 degrees, 24 minutes. We're looking for the distance between them, at least how far north this is of that. 3964. Okay. So, can you make that computation? Still no? Are you sure? Well, remember, we're doing an arc length problem, s equals r theta. And what has to be true about theta? Well, theta has to be in radians, and they're giving me degrees. So I'm going to have to convert these degrees to radians in order to use this formula. But I don't want this angle, and I don't want this angle. I want this one, which is the difference between these angles. Now, you're welcome to try and do the subtraction here, but I don't like carrying in base 60. So instead, I'm going to decimalize each of these. I've got 40 degrees and 24 minutes. And so that is 40.4 degrees. Now Palermo, 30 degrees, 7 minutes, and 55.38 green seconds. And so that's 30.13205 degrees. So I'm going to take 40.4 and I'm going to subtract that one. And that gives me that theta is 10.26795 degrees. There's my theta. So is it now just a matter of saying the radius is 3964 times 10.26795? No, that's a recipe for getting the problem wrong. Why? Because when we use s equals r theta, even if we're tired and sleepy, we still have to know that that is in radians. And that is not radians yet. So you have to convert that. Pi over 180. Okay, so I'm going to multiply this by pi, and I'm going to divide by 180. Okay, so in radians, that's 0.179209534 9. So I take that number and multiply by the radius of the Earth, and I get that the distance is 710.387 miles. Okay? All right. Well, we reviewed a bunch of things. How about one last one? I just can't help myself. One last one. The terminal side of an angle passes through the point -7, -24. Find all 6 trig function values. Okay. So yeah, I'm looking for sine of theta. I'm looking for cosine of theta. I'm looking for tangent of theta. But I'm also looking for cosecant of theta, secant of theta, and cotangent of theta. So how am I going to do this? Well, my recommendation is you draw a triangle. Remember, never to the y-axis, always to the x-axis. -7, -24. And either with Pythagorean theorem or knowing your Pythagorean triples, you should recognize that that's 25. All right, well, there's our angle. And sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. 24 over 7. Now, these other three, they're just the reciprocals. Negative 25 over 24, negative 25 over 7, and 7 over 24. And hey, before you yell at me and say, but Mr. Googly, you said the hypotenuse could never be negative. Yeah, but here in math land, the convention is actually kind of to frown on people who put the negative in the denominator. I agree. Negative 3/4 is the same as 3 over negative 4. But the convention is to put the negative either in top or in front. Now, that doesn't mean I'm going to mark it wrong because you put the negative in the bottom. I just wanted to explain why it was that you were seeing me putting it in the top. I'm not implying that the hypotenuse is a negative number. No, no, no. I'm just following this other convention that says, yeah, we don't really do that negative in the bottom thing that kids like to do. All right. Well, I hope you're feeling ready and prepared. And if not, I hope you're reaching out for some help. We'd love to help you. And good luck on your assessment. Take care.